So, good afternoon, dear students. Today we are going to be solve few numericals based on the Morse circles and analytical method. So, let's move to the next slide. So, the problem statement is like this: at a point in strained material, a stress pattern is shown in the figure. Determine. This is the question, and this figure is mentioned in the question. According to this figure, this diagram, we have to be following these four things. First one is the normal and shear stresses on plane AC. AC means this inclined plane, as shown for theta is equal to 30 degrees, that theta is 30 degrees given in the question. Then second one, we have to be calculate here magnitude and nature of the principal stresses. So first we have to be find the magnitude, means sigma 1 and sigma 2. Then nature of the principal stress means, is it clockwise, it is a tensile or compressive. Then orientation of principal stress, it means we have to be find the value of theta 1 and theta 2. And next, fourth one is to find out the maximum shear stress, and orientation of plan having the maximum shear stress means we have to be need to be find the theta s also. This is all about the question, and you can see this diagram. So in this diagram, there are the stresses pattern in mention. So in toward the x-axis, sigma x is 75 megapascal, and sigma y, that is a minus 90 megapascal, means it is a compressive in nature. And shear stress is mentioned, that is a 50 megapascal. So we can say the shear stress which is acting on a plane AB, that is a positive one because it is moving clockwise direction. And the shear stress acting on this plane where the sigma y is acting, that is an anti-clockwise. It means it's a negative one. And we have also the theta value is taken minus 30. Minus 30 because of that, in initially when we are derive the formula for finding the normal and shear stress on inclined plane, at that time we have taken this theta at this position, this here, this position here, and now given is this. So we have to be transform this. So simply you just write minus theta when in the actual formula, so it will be automatically come to there. Or in other things, you can do one thing, you can also write this 90 minus theta, and you put the 90 minus theta in respective places. वो भी हो सकता है, doesn't matter. Now this numerical we will solve by using two methods. One is analytical method. Analytical method means we are going to be use the formula, simple formula what we have derived in the previous classes. And second was same numerical we will solve with the help of Morse circle method. So we will see in coming half an hour how to solve this problem by two methods. One is analytical, another is the graphical or Morse circle method. Okay, let's move ahead. So normal stress on inclined plane. So we know that the formula for that, sigma theta is equal to sigma y plus sigma x by 2 plus sigma y minus sigma x by 2 cos 2 theta plus tau sin 2 theta. This is a simple formula what we have discussed in the previous classes. Okay, just put the respective value of sigma x and sigma y. We all know that sigma x is 75 megapascal and sigma y is minus 90, minus because of its nature of compressive. Just put the values with the sign here. You can see here 75 minus 90, minus 90 and 75, and cos 2 theta. So where 2 theta I have already told you, either you can write here 90 minus theta, or 6 you can means it means the 60, or you can write this, you will get the same value. Now so after the solving this, we have got the normal stress on the inclined plane AC is 77.05 megapascal. So this is a simple. Now we are going to be find the shear stress on inclined plane AC. So this is a simple formula of the shear stress, that is sigma y minus sigma x by 2 sine 2 theta minus tau cos 2 theta. And now we will put the value with the sign. So sigma y is minus 90. Okay, sigma y is minus 90, and this must be something missing. Okay, you just write here minus 90 must be there, minus 75, because this we have to consider this sign. So this value might be changed. Okay, no problem. I'll do that when I will share this.
minus 75 होगा ना सर?
Yes, yes, yes. When I will share this slide, I will be correct it. But you just solve by using your calculator, then you will get the right answer. No problem. Might be this answer is right, because sometimes during the typing we miss it. So it's happened. Might be this answer is right. Okay. So let's come to the next part, the calculation of the principal stresses. So principal stresses, so we know that the formula for the principal stress is sigma 1 is equal to sigma x plus sigma y by 2 plus under root of sigma y minus sigma x by 2 plus tau x square. Just put the all relative value here. तो आपने जैसे इसमें सारी वैल्यू रखी, तो ये कितना आ गया 88.96 मेगा पास्कल. सारी वैल्यू आप रख लेना घर में फिर से. मैं अभी आई विल बी शेयर दिस पीपीटी टू यू, आप घर में प्लीज करके देख लेना. सो आपको बिल्कुल थोड़ा सा कॉन्फिडेंस आ जाएगा. तो हाउ वी ऑब्टेन दिस ऑल दिस वैल्यूज. नाउ time to find the second principal stress or minimum principal stress. You know that the formula of that, what is the formula of that? Sigma 2 is sigma x plus sigma y by 2 minus, just you put the sign minus here in between these two, so it become the formula for the minimum principal stress. So like this, and you put the all relative values. Here you put sigma x in place of sigma x, put the value of 75 and sigma y minus 90, and here also, and the final answer is minus 103.97 megapascal. So dear students, because it's have come minus sign, it means the second principal stress is a compressive in nature, and this is asked by the question also. Also write the nature. So here sigma 2 is the compressive nature and sigma 1 is the tensile in nature. So we can write here in bracket T. So it will be sigma T, sigma 1 is tensile in nature, sigma 2 is the compressive in nature. When we are written here sigma C, so here we have to be move the minus sign, we have to be remove the minus sign. So this you remember every time when you put this C as a bracket, so we have to be remove this minus sign from here. So next, the orientation of principal stress. आपको फॉर्मूला पता है क्या है? tan 2 theta 1 is equal to 2 tau upon sigma y minus sigma x. Put the all relative value. जैसे आपने सारी वैल्यू पुट करी, क्या रखा आपने यहाँ? tau is 50 was given, दिया था ना 50 was given. So okay, and all the relative values are put here. Sigma y minus 90 and is plus 75, and these values came here, and then आप इसके you just solve it. So आपको आया फाइनल आंसर इज minus 15.61 degree. So how to calculate the sigma 2, just add the 90 degree to the sigma 1, you will get the sigma 2. I did the same here. Okay, यहाँ तक कोई प्रॉब्लम नहीं है. आई थिंक यू if you have remember this formula, तो please I request you all write these formula in front of your study table. So each and every day, if you see that, so one day it will be print in your mind, and it will be help you a lot, because in the coming chapter it will be again and again we will be use these formulas. Okay, so this is a very important formula for the principal stress. Now, turn to calculate the maximum shear stress and orientation of plane. So, formula for the maximum shear stress, you just write down plus minus under root of sigma y minus sigma x by 2 का whole square plus tau square, and put all respective value, और हमको यहाँ से मिला, so that is plus minus 96.46 megapascal by plus minus, because tau always acting in the two sign together, one is the plus, one is another is the minus. So here the plus minus 96.46 megapascal. So now the turn to find out the angle where it is acting. So formula for angle of the shear, to calculate the shear stress, just as simple is sigma y minus sigma x upon 2 tau, and just put all respective value here, and we will be obtain that 58.78, and just half it, so 29.78 degree. So this is all about the analytical method, and analytical method means we have to be use some standard formula what we have derived in previously. तो simply आपको use करना है standard formulas, ठीक है? So these formula somewhere we have derived itself. Now great. So we have, so now you have understood that we have two methods to solve such kind of problem. One is the analytical method and another is the graphical method. So now move to the graphical method to find the all respective values what we have already calculated by using the analytical method. Let's move to the graphical method. So
सर दोनों मेथड से वैल्यू सेम ही आएंगी?
Yes, value will come same. So let's move to the graphical method. So this data is given, you might remember that. So we have sigma x 75 megapascal is given in the question, and corresponding value of tau is plus 50 megapascal, because in where the sigma x is acting and the tau is in a clockwise direction, that's why it's a positive, and opposite sigma y is equal to minus 90, and in the minus 90 in which plane is acting, there is the shear stress is minus 50. So this is the given data, you write over here. Then the turn, first you draw x axis, so this is x axis, then y axis, okay, then you put all corresponding values here. चलिए पहले हम लिखते हैं OA sigma x, first we put the value of sigma x is 75. so उसके लिए we have to be take a scale आप अपनी मर्जी से ले सकते हो, कोई प्रॉब्लम नहीं है. either you can take that 15, आप 15 भी ले सकते हो, 20 भी ले सकते हो, 10 भी ले सकते हो, it's your will. But if you take the 10, so your this diagram become double what we will obtain by this scale. You remember this. So this thing you will be understand only if you are practicing continuously. After solving 5 to 10 numericals, you will be understood. So how to take the scale, and at that particular scale, how much space is required for that? It's come by the practicing. So please do the practice, dear student. It's really needed. So now come to the question. We have taken the scale 20 megapascal is equal to 10 mm. This is my scale, or 1 centimeter we can say. So first value we have chosen OA. OA is how much? Is 75. Just divide 75 by 20. So it will be 3 point, how much? 3.45, 75. है ना? So you take,
3.75.
yes. So from from O to A. Mark A at that distance. Then you see what is the shear stress corresponding to the sigma x. That is 50 megapascal, and the sign is positive. So it's go upward. How much? That divide by 20 is 2.5.
5.
Great. Then this is a 2.5. The value of this is 75 and 50. The coordinate of point B. Now you take the O to C. C is minus 90 megapascal divided by 20. So it has become 4.5. Where? Toward this direction, negative side, because it is in minus sign. So toward this 4.5.
5.
Okay, so this C at the 4.5, and the value of tau is given minus. It means go downward. Okay, of downward 2.5 centimeter.
5.
Okay, then what is the next
Okay,
step?
sir.
Just draw a line between B to
BD को
D.
मिला देंगे.
B to D. Okay.
B to D.
Okay, I have drawn. Then mark the intersection point of the line BD and this x-axis line. So it's called E. Okay. Now take the E as a center. Okay. Understood? So
Yes, sir.
E as a center and BD as a diameter. Draw a circle, and that circle will be a what? More circle. So
More circle.
this, you drawn this circle by taking the center E. So see, OH, this O and H, you just measure this distance O and H, and it approximately is more than 4.4. So 4.4, you just multiply by the given scale, taken scale. So it's come 88.97 megapascal. Okay, understood? Next, you measure this O to I, and this is approximately 5.1, more than 5.2. You can say. So just multiply by the given scale. So it's come 103.97 megapascal, but negative sign because it is located at left side of y-axis. So it's a negative. So negative 103.97 megapascal. Now the turn to find the orientation of the principal plane, or where the principal plane are acting. So हम क्या करते हैं? We just measure the angle between this BD to OH line, this line. So let's move. So this angle. So this angle is approximately, that is 31.22. So I have written here 32. Exactly is 30.22, and just half these values. So you will get 15.161. Dear student, it's sometimes it's varying, but little amount. It doesn't matter. Suppose X student solve, and he has got 31.22. Someone solve and he might be get 31.4555. It doesn't matter. It's the right answer because it's a happen in the graphical method. It's quite possible. So कभी भी घबराना मत, नहीं, थोड़ा बहुत चलेगा. Okay, let's come to the here. So now how to find the theta 2? Just at 90 degree you will get the theta 2 is 74.39. Now the find the maximum tau max. तो सिंपली आप लोग मेजर कर लो जेई को, जस्ट मेजर द जेई मेजर कर लीजिए, जेई को जितना भी है उसको स्केल से मल्टीप्लाई कर दीजिए, यू विल गेट द मैक्सिमम टाउ. सो इट्स इज ए 96.47. सो ये दिस इज अ वैल्यू ऑफ टाउ. नाउ अब if it is asked in the question, find the plane, shear plane. So what will we do? You just measure this. Okay, let's move ahead. Find the value of sigma theta and tau theta. How it is? Because in question you might be remember that the inclination of the plane is given 30 degree. So you just double that 30. डबल करेंगे तो कितना होगा? कितना करेंगे? डबल करेंगे तो 60. ठीक है. और वो एंगल फ्रॉम वेयर यू आर गोइंग टू बी मेजर फ्रॉम बी ई एंड कमिंग एंगल, कमिंग पॉइंट विच आर गोइंग टू बी कम हियर समवेयर हियर. सो लेट्स सी हियर. सो दिस एंगल बिटवीन, आई एम शोइंग यू दिस एंगल, आपने ये वाला एंगल मेजर किया है, ये कितना है? 60. दिस इज अ 60 बिकॉज इन क्वेश्चन गिवन 30, तो 30 का डबल इज 60 और हियर मस्ट बी अ बी. आई हैव रिटन ए, सो इज बी ई एम, नॉट ए ई एम, इट्स बी ई एम. आप करेक्ट प्लीज. सो आप ये 60 डिग्री है बेटा, ये 60 डिग्री है. ओके, एंड 60 डिग्री में इंटरसेक्टिंग ये नया पॉइंट मिल गया आपको M. इस पॉइंट के करस्पॉन्डिंग यू पुट यू ड्रा अ परपेंडिकुलर ऑन x एक्सिस. दिस इज अ न्यू पॉइंट इज K. यू मेजर E K, sorry E नहीं, OK, नॉट E K. इट्स मेजर ऑल मेजरमेंट डन बाय द ओरिजिन. ये आप याद रखिए, यहाँ से मेजरमेंट ओरिजिन से होगा. किसके लिए? नॉर्मल शेयर स्ट्रेस के लिए. सो यू मेजर OK here. The OK gives to sigma theta and you measure this MK and it's give O tau theta. So this is the all about this numerical. And ये देखिए, ये भी क्वेश्चन में पूछा था, what is the orientation of shear plane to just measure this angle, and this angle is 58. So 2 theta s will be 58 and theta s is equal to just half of this. ठीक है. So this is all about dear. So हम ऐसा इस तरह से we can solve this kind of numerical in future. If this kind of numerical coming in examination, now I hope you are able to solve such kind of the problem. My dear student, when you are going to practice in your home, so please draw this in a graph paper. Graph paper will give the appropriate result to you. So please keep practicing in the graph paper for getting the proper and good result for this particular chapter. So now let's move to the, so this is all about today class. So hope all are